All right, welcome back to Dilemmas Concepts. Today we're looking at July 2021, question 6, and it reads, Brown, our farmer Brown makes troughs to feed his animal. We're right here using wood that is 5 centimeters thick, as shown in the diagram below. All right, so the troughs are rectangular base, open at the top, and have external dimension of 300 by 190 by 160 centimeters. So there it is that we have the dimension of the troughs that were made by this farmer. All right, let us see what the questions are like. First question says, show by calculation that the internal, so we're gonna highlight the word internal here, that the internal capacity / volume of the trough is 8,091,000 cm cube. All right, so basically what we want to do is to use the external dimension, understanding the thickness, which is 5 centimeters, and we would have to subtract that from both sides because we want to know what is the capacity, right? The ability to hold, how much? All right, so this 300, which is external, we would have to take 5 from this side and take 5 from the other side. So technically we're taking 10 from it. So then the internal dimensions for that would be 290, all right? Taking 10 from that. From the 190, taking 5 from this side and 5 from the other side will ultimately take 10. So this is 180. And in terms of the height on the inside, we would have only take 5 from the bottom because it is open at the top. So this height now becomes 155, all right? So basically we're subtracting the thickness, which is 5 cm all the way around, all right? So the internal dimensions will be different from the external. So we're gonna put this together and we want to prove that we'll get 8,091,000 cm cube. So here are the numbers that we're putting together. 290 cm times 180 times 155. So put that on our calculator. This gave us 8,091,000 cm cube. All right, so we would have gotten the marks for that. All right, let's look at the next question. Question says, calculate the volume of wood needed to make the trough, right? The volume of wood needed to make the trough. Basically, what we're going to do here is we're going to find the external volume and subtract the internal volume. So basically, we could come up with a quick formula that says the volume of wood needed is equal to our external volume. So we're going to find the external volume, subtract the internal volume or capacity. We just found that. So let's go for the external volume. For the external volume, we have to use the measurement from the outside, which is 300 by 190 by 160. So the external measurements are what we want to find the external volume. So let's get the external volume. So that's the 300 by 190. So 300 by 190 times 160. So we're going on the outside. 9,120,000. So that's the external. As we said before, we want to find the external and subtract the internal from it. So we got those. So we're talking the external here is a 9,120,000 and we're subtracting 8,091,000. This will give us the volume of wood. So now I'm getting 1,029,000. Yeah, 1,029,000 cm cube. That is the volume of wood needed, all right, to make the trough. All right, let's go to question 3. Let me see what it says. It says, question C says, Farmer Brown must paint the internal surface. So he's going to paint on the inside now of the trough. Given that 1 gallon of paint covers approximately 280,000 cm3 of surface, determine the total amount of paint in liters that is needed to paint the internal surface of the trough. All right, so in other words then, and then we're seeing where 1 gallon is equivalent to 3.79 liters. So the thing is that we want the answers in liters. We could focus on that later. What we need to know right now is the total internal or interior surface that needs to be painted. So we're going to have to look at the diagram above and come up with the measurements to get the internal surface. And then from there, we'll use the 280,000 here to work it out. So let's find the internal surface first. We definitely need the internal surface to be painted, right? So in looking at this, the internal surface, we could probably just work it right here. The internal surface, go back beside the diagram. Internal surface, want all of that. All right, we're talking about twin ideas. This 190 here, so the 190 here will multiply by the 155 going up, and it is going to be over this side as well. So whatever we have on the inside here, we'll have it on the other side. So I'm going to write them down one at a time. So we'll definitely have 290 times 155, and we're going to have that 2 times, yeah? So you'll have that 2 times, yeah, the front and it's at the back. It's right here on the inside around here, and then it is over here, right here. That's one pair. Let's go for the other pair. The other pair is going to be on this side, on the inside here. So that's a 180 times the 155, and it's going to be a twin. It's going to be on the other side as well. So 180 times 155. So we're adding that 180 times 155, and we have it 2 times. And then we actually have the bottom surface to add to that. So the bottom surface is a combination of the 290 and the 180, because that's the bottom surface. So 290 times 180. All right, so we need to put together these measurements and then work out. So let us just work this out. 290 times the 155. You're going to double that. And this part gave us 89,900. We have 180 times 155 times 2. And that part gave us 55,800 plus 290 times 180. 52,200. Let's total this plus 55,800 plus 89900. All right, so we're looking at 197,900 cm square. So this is the surface that will be painted on the inside right now. Definitely we're seeing that it is less than 280. So we definitely know that it's not going to take a gallon to do this, right? It's going to be less than a gallon to actually paint this. So let's work that out up there, and we got 197,900 cm square. All right, so that is the surface that we have to be painted. But remember now that this gallon can paint 280. So we're going to divide. So if I want to know the gallon that we need, so I'm going to write gallon needed, or we could say the number of gallon of paint needed can be found by saying this 197,900, we're going to divide it by 280,000. All right, and it's going to tell us how many gallons we actually need. So 197,900 divided by 280. And we actually have 0.707. All right, so we have 0.707. This is the amount of gallon that is needed. But the question does not want it in gallon. The question wants the answer in liters. Remember though, 1 gallon would have given 3.79 liters. So all we have to do is to multiply. So I'm going to convert this now. So the liters needed is equal to 0.707 times 3.79. Will land us 2.68. All right, liters. I'm getting 2.6 liters of paint he would need to paint all that internal surface right there. And that's how you go about dealing with that.